Today's notes are brought to you by the boys lacrosse team. Our title is 10-2, Areas of Trapezoids, Rhombuses, and Kites. You're going to need to set up your notes with 3 different sections, 1, 2, 3. In the bottom section, you're going to have 4 examples, and in the top section, you'll have 2 boxes and then some diagrams in there. Well, before we move into our notes today, I wanted to kind of remind you of what we learned last class. This was our opening slide of last class, and our title was Areas of Parallelograms and Triangles. Is there anything in this title that we have already learned how to find the area of? A parallelogram, perchance? Yeah. A rhombus is a parallelogram. We already know how to find the area of a rhombus. It's base times height. But today I'm going to show you another way to find the area of a rhombus, and it has a lot to do with its relationship with a kite. So please note that you can find the area of a rhombus using the notes that we found last class, but today I'm going to show you another way to find the area of a rhombus. I'd like you to start by drawing 2 boxes and titling the area of a trapezoid and the area of a rhombus or kite, and then drawing 2 trapezoids, a rhombus, and a kite below those boxes. The area of a trapezoid is base 1 plus base 2 times the height divided by 2. Where B1 is base 1, and B2 is base 2, and H is the height. The area of a rhombus or a kite, to find it, it would be diagonal 1 times diagonal 2 cut in half. That's diagonal 1, and this would be diagonal 2. Last time we asked the question, how do you find the base and how do you find the height? It's more complicated here because we're looking at 2 bases and a height and 2 different diagonals. So let's first look at our trapezoids and identify that. Last class we used red as our height, and we knew that the height is always perpendicular. So we were looking for right angles. That maintains the same. The base here is perpendicular to the height, and in this case there are 2 lines that are perpendicular. So those 2 blue lines represent base 1 and base 2. The order that you put them in does not matter. So you could say the one at the bottom is base 1 or the one at the top is base 1. It really doesn't matter. So blue is our base. For the diagonals, I'm going to change colors here to green. A rhombus and a kite have one thing in common, and it's just this. The diagonals of a rhombus and the diagonals of a kite are perpendicular. And that is why they both use this formula here. So here are the diagonals. Diagonal 1 and diagonal 2 are entire lengths. So it would be this entire length times this entire length. That's diagonal 1 and diagonal 2. And again, they are interchangeable. In the bottom section of your notes, what I'd like you to do is to copy down these 4 examples. Of course, include all of the directions, the diagrams, and any red labeled measurements. When you're ready, unpause the video and we'll go through some of those examples. For our first example, I first asked myself, what have they given me? This is clearly a trapezoid, so I'm going to go ahead and write my trapezoid area formula, which is base 1 plus base 2 times the height divided by 2. I'm going to check to see if I have all those things. The height makes a 90-degree angle, so I could choose this value here or this value here. Those are the 2 places I'm going to be looking. And that means the base is perpendicular. So here's one base, and here is my other base. What I notice is I do have one base as being 5. I have base 2 as this entire value, which is 7, but I don't have a height. I do have this 60-degree angle over here, and that automatically makes me think of a 30, 60, 90 triangle. Here's my 60-degree angle. This is 30 degrees, even though they didn't say anything. And I know this is 2 meters. Now here's the pattern that we learned last chapter. if this is 30 degrees and this is 60 degrees, the shortest side represents x, the hypotenuse is 2 times the shortest side, and across from the 60-degree angle, that's an arrow, is the shortest legs times the square root of 3. Now what I'm looking for, if you might remember, I'm looking for this side right here. So I know the shortest side is 2 meters. That means that this must be x square root 3 or 2 square root 3. So what I'm going to go ahead and do is I'm going to erase my question mark because I know it now. Without doing really any calculations, I know that the height is 2 square root 3. There we go. Sorry. Okay, now we're just going to plug those values in. So I'll just go ahead and write my height is 2 square root 3. With these 3 values, I should be able to find my area. Base 1 is 5, base 2 is 7. Remember, those are interchangeable. My height is 2 square root 3 divided by 2. My area is, I'm going to add first, that's 12 times 2 square root 3 divided by 2. 12 times 2 is 24. Square root 3 divided by 2. That means that my area is 12 square root 3 meters squared. That's it. For this problem, instead of giving us a diagram, they're giving us a description. So we're going to have to draw a diagram from the descriptions in the words that they're giving us. So it says, find the area of an isosceles trapezoid with legs 5, 5, 6, and 12. Now, a couple keywords I'm noticing is isosceles trapezoid, that's the shape I'm going to draw, and then they've given me all these values. So I'm going to start by drawing an isosceles trapezoid. Now, I know an isosceles trapezoid has 2 congruent sides, we call those the legs, and it also has 2 congruent angles, and maybe that'll come in handy, we'll see. Now they've given us some values here. If these 2 sides are congruent, these are clearly the sides that are 5. This is my shorter side, and this side would be 12. Now, since it's a trapezoid, I already know that the formula I'm going to use is base 1 plus base 2 times the height cut in half. So I'm going to need to find the base 1 and the height, and the base 2. So the height is this side right here that makes a right angle. And it's clearly not there. I don't know that value. But I do know the bases are going to be perpendicular. So that's my 6 and my 12. So I do know that base 1, I'm going to make that 6. And I do know my base 2 is 12. But I do not know what my height is. And I'm going to have to find that before I can find my area. The first thing I want you to think about is if, let me grab a different colored pen here. Okay. If this section is 6, okay, and I draw down these 2 heights, or these 2 altitudes, I'm making a rectangle. This side would be 6. I don't know what these 2 heights are, but I know they're going to be equal. What would this be right here? It's not 12, because this whole line is 12. It's less than 12. And if this is a rectangle, whatever this side is should be equal to this side. If that's true, then that would mean this little piece right here would be 6. So in that case, what would this be? And what would this be? Well, let's think about this. This whole thing is 12, and I'm taking this 6 away. That means there would be 6 remaining. That would have to be shared equally here. Why equally? Because these 2 triangles are clearly congruent. So how would I separate 6 equally into 2 pieces? Well, dividing by 2. I'm going to make my picture a little clearer here. They told me that the bottom base was 12. But if I draw in this rectangle piece, I know that this side, let me get back to my pen, this side would be equal to this side, and that way I can take my 12 and split it equally here. Now remember, our goal was to find this height. Now, how does that help me to find this value is 3, this value is 6, and this value is 3? Well, let's take a closer look at one of these triangles. So right here I have this labeled as 3, this labeled as 5, and since I don't know what this value is, I'm going to call it x. Now let's see, you have a right triangle, you have 2 of the 3 values. How could you find that third value? Oh, that's the Pythagorean theorem. Pythagorean theorem, which says a squared plus b squared equals c squared. A and b are the legs, that's these sides, that's a and b, and c is the hypotenuse, which is this guy, the one across from the right angle. So if I plug in those values, let's see what we get. We'll say a is 3 squared, b is x squared, and c is 5 squared. I'm going to have to scroll down just a little bit. I get 9 plus x squared equals 25. I'm going to subtract 9 from both sides. I get x squared equals 16. Oh, I lied. I'm going to need to go a little bit further smaller. I'm going to square root both sides. X equals 4. That means that this height piece right here is 4, and I can now label it here. Now I can say my height is 4, and if I, can I move it? Yeah, there we go. Now I can plug my values in. So my area is, base 1 I knew was 6, base 2 was 12, and I found that the height was 4 by doing the Pythagorean theorem. I'm going to cut that in half. So my area is, I add first 18 times 4 divided by 2. I'm going to have to multiply 18 times 4. That's 32. 4 times 1 is 4 plus 3, 7. My area is 72 divided by 2, which is 36. And they didn't give us any units, so I'm going to call this units squared. And that's how you would find the area of an isosceles trapezoid. For this example, first I'm going to look at my picture and ask myself, what have I been given? Clearly this is a kite, and I know the formula for the area of a kite is diagonal 1 times diagonal 2 cut in half. Now let's find those values. I need diagonal 1 and diagonal 2. I'm going to call diagonal 1 this longer diagonal, which is this 5 meter part plus this 2 meter part. That means diagonal 1 would be 2 plus 5, that's 7 meters. My second diagonal I'll call going across this way. That would be 3 meters and 3 meters, or 6 meters. Well, it's as easy as that. I'm going to take those values and plug those in. Diagonal 1 I called 7 meters, diagonal 2 6 meters, and that's cut in half. 7 times 6 is 42. Meters times meters is meters squared. All I have to do now is cut that in half. The area of this kite is 21 meters squared. This last example you're going to do on your own, and of course the first thing I want you to do is to look at the figure you've been given. This is clearly a weird looking shape, so let's look at what you've got. This top shape has 4 sides, all the sides are congruent, and the diagonals bisect each other. But I can also see that right here the diagonals are perpendicular. That means even though all the sides are the same, this isn't a square. It means that this right here is a rhombus. So I'm going to go ahead and label that. You have a rhombus on the top. The bottom section also has 4 sides, and this line is parallel to this line. Well, that's a trapezoid. So this bottom shape is a trapezoid. What you're going to need to do to find the total area, because that's what I'm looking for, is not just the area of one, but the area of both added together. You're going to need to find the area of the rhombus first, then the area of the trapezoid, add them together, and that will be your total area. Now just to make sure you can see these, that's 3 meters, 3 meters, 2 meters, 2 meters, 6 meters, 4 meters, and 8 meters. I hope that helps. Good luck, and I will check this example when I check your notes.